And the last part in question 1.2 part F. Again, here we don't have explicit expression for the output signal, but we have the relationship between input and output signals, and that's enough. First step, we assume the input signal is x1t, and that make this relationship between input and output dy1t over dt plus y1 squared t equals input. And for the second input, if the input is x2t, then the relationship between input and output is like dy2t divided by dt plus y2 squared t, and this equals the input, which is x2t. All right, and from the definition of linear system, we know in a linear system, if the input is alpha x1t plus beta x2t, then that should give alpha y1t plus beta y2t at the output. And well, that means if this system is a linear system, then we would have I can replace all y1t by alpha y1t and all x1t by alpha x1t in the relationship between input and output. And also I can replace the same y2t by alpha y2t and x2t, sorry, this is beta, not alpha. Okay, well, that means here we would have, in a linear system, we would have alpha dy 1t over dt plus alpha y1 squared, that equals alpha x1t. Okay, and well, instead of this I can write alpha squared y1 squared t. Okay, so let me replace that by alpha squared y squared t, and I can do the same for this. It would be d beta dy 2t divided by dt plus beta squared y squared t, that equals beta x2t. Okay. Now, in the third step, assume that the input signal is the combination of x1t and x2t. Okay, if the system is linear system, then we get actually instead of y, we would have alpha y1t plus beta y2t divided by dt and plus alpha y1t plus beta y2t squared. This equals input, and input is alpha x1t plus beta x2t. Okay, now I need to expand this. Okay, let's expand this, and by expanding this, then we would have alpha dy1, okay, this is easy, plus beta dy2t divided by dt. And if I expand this, then you would have this guy squared plus this guy squared plus 2 times this one times this one. Okay, so let's write that. We would have alpha dy1t dt plus beta dy2t dt plus alpha squared y1t squared plus beta squared y2t squared plus 2 alpha times 2 times alpha times beta times y1t times y2t equals alpha x1t plus beta x2t. All right, if I compare this part, okay, this should be equal to this guy plus this guy. Okay, so I should check for each item here in these two expressions here. I should check for each item and then find that in this expression here. So let's see. Okay, I would label them. I would label this one by 1, and that's here. We have 6 terms. I'm not sure we have 6 different colors, but let's try. Okay, I label this one by 2, and you have it here. Okay, good. I have this one here. I label it by 3, and that's here. Okay, we have all expressions, the first expressions. This one, I label it 4, and that's here. Good. Let's use this color. For this one, I label it 5, and that's here. Okay. For this one, I label it by 6, and it's here. And finally, we have 1 terms left here that we don't have in the linear system. I mean, if the system is linear, we shouldn't have this in the output. So that means for inputs, for an input like this, for an input like alpha x1t plus beta x2t, the system output is not alpha y1t plus beta y2t. So that means this system is not a linear system. So I write it here. It's a non-linear system.